I am audible. Guys, good evening.
Good evening, sir.
Should I audible? Hello?
Yes, sir, you're
Jabira,
audible.
slide is visible.
Yes, sir, visible, sir.
So, good evening, everyone. This is Ashok Kumar, PMRB scholar, and TA teaching assistant on the sensory extra to B. Uh, have you any doubt regarding previous week, like week 1 to week 5, week 6? Please, I will take first your doubt and then we'll move some questions and some theoretical part of that portions. So, feel free to ask any doubt because it is a discussion class, so I need a discussion from that classroom also. That Banala, Jabira, I think you joined the first time.
Yes, sir.
So, are you PhD scholar or BTech MTech?
I'm an UG student, sir.
Which college?
So, Sri Ishwar of Engineering.
Which?
Sri Ishwar College of Engineering, sir.
Okay, okay, okay. So,
Tamil Nadu.
yeah, yeah. Tell me. Yes,
Sir,
Jabira.
actually, my doubt is in week 7, sir. Yes, sir. Week
Yes,
7.
sir. I will take week 7 also. No problem.
Okay, sir.
What is your doubt?
Sir, it's about IR sensor, sir. The
Yes.
performance of IR sensor, sir.
Okay, but that you have to post it on ask to questions form also that.
Yes, sir. I have already asked in discussion forum also, sir.
Yes, 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 yes. I have gone through that your doubt also that.
Yes, sir.
The doubt is your Jabira. 1 minute.
Okay, sir.
That that black body does not reflect backlight from the transmitter to receiver of the IR sensor. That means black body is insensitive to IR sensor, right? But answer of the sixth question that your that assignment questions, I think. Your quiz questions is doubt that I think, huh?
Yes,
It is.
sir. There were
Have you submitted
already
quiz?
two responses regarding this, sir.
Have you submitted quiz? Have you submitted this quiz?
Yes, sir. The due date was 8 18, I guess, sir.
Okay. 1 minute. So you think that it should be not sensitive in the black color? Your doubt is right there, na?
Yes, sir. And my doubt is also the answers they suggested, sir.
Okay, they suggested that it is more sensible in the black body,
Yes, sir. High sensitivity.
high sensitivity. Okay. And other week class, how is your marks and quiz you have attempted? It is good, okay, or
Yes, sir. For me, it's okay, sir.
okay.
I didn't face any difficulties in that, sir.
So how was your that performance?
So it's 80, 90. However, there will be at least one question which is going wrong, sir.
Okay, is in this week 7.
Yes, sir.
Okay, okay. Otherwise, it is okay.
Yes, sir.
Okay, okay. So, can you explain the working principle of the IR sensor?
So there were two lights, sir, which one is transmitter and one other one is receiver. Uh,
Okay,
when the transmitter transmits a signal or a light, infrared rays, if if there is a body or there is a thing that reflects, then the black light which is receiver will receives a signal, then it is sensible. Then it is sensed, sir.
Okay.
Or in the case of black body, it completely absorbs a signal or radiation which is hitting it, hitting itself. So that is why I have raised a question like, how come the perfect black body can reflect radiation, sir? If it is
Actually,
so,
yes, yes, tell me.
then how the receiver can receive a signal? That is not my question, sir.
Jabira,
Sir,
yeah, tell me. We continue.
sir, I've been continuing. Sir, in my question, like in week 7, there is a question like sensor has the highest sensitivity when the target surface is black, perfect black body.
That is why which of the following the sensor has the highest sensitivity when the target surface is perfectly black
Perfect
body.
black body, yes, sir.
Ah,
To my knowledge, if it is a perfect black body, it will never reflect or transmit the radiation, sir. It's completely, it entirely
what
absorbs the radiation, sir.
that you can first that what is the sensor will do. I will 1 minute. Okay, like that. This is the our any device that okay,
Okay,
like
sir.
that. This is the my silicon substrate. Okay,
Okay, sir.
we have to use the different substrate to fabricate the sensor like that. Someone the silicon is less expensive, someone use the glass, quartz. These are the substrate, that base material. Okay, then what happened to fabricate the sensor? We have to deposit some oxide layer or some material like that, like graphene, MOS2, WS2, ZNO, magnesium oxide. I think you have heard of that name in the chemistry and that everything. This you have heard about the periodic table, that silicon and everything.
Yes, sir.
So what happened that we have to deposit the layer on that silicon substrate. Okay.
Okay, sir.
What is the black body means? The black material. That color of the material is the black. Like that, carbon is the black. Okay, black phosphorus is in also come in the black color. Graphene is also come like the black color. Okay, so what happen in the sensor that you have understand the basic physics, that light will be completely absorbed by the sensor. Okay, black body,
Yes, sir.
it will be not transmitted or reflected any light. It is
Yes.
correct.
Yes, sir.
But in case of the sensor, we need the maximum absorption. Like that some light will be fall, that IR light. That IR light have the wavelength of above the 700 nanometer. Okay, that light source, that wavelength is above the 700 nanometer. That will be called as the infrared light. That will not visible by our eye. I am correct.
Yes, sir.
So what will happen when this light will be fall on this material? It will be absorbed. Material will be absorb this light. And what happen when the material will be absorb this light? That electron and hole pair will be generated. Okay.
Sir.
What what we need the maximum absorption of the light in case of the IR detector. Okay.
Okay,
If you
sir.
have you heard about photo detector? Have you principle of the photo detector?
Sorry, sir. I have no clue.
Have you know the principle of the photo detector?
No, sir.
What will be photo detector will be working on the principle of the absorption of light. It will be have the four basic mechanism, either photoconductive effect, photovoltaic, photo gating, bolerimetric effect. these are the principle behind that photodetector. Like in case of the photoconductivity, what happened that when the light will be falls on the many materials, electron and hole pair will be generated in the valence band and it will be moved in the conduction band.
Okay, sir.
You you read that semiconductor electronics. You aware about that electron valence band and conduction band. When the
Yes.
temperature will be increasing, that our electron will be moved from valence band to conduction band and current will be increased.
Yes, sir.
Same case in the that IR photodetector. So why they have said that black body will be absorb the more light? You are saying that a black body will be absorb the more light.
Yes, sir.
It means it will be generated more number of the electron and hole pair.
Yes, sir.
So what will happen? It will be give the more current
Yes, sir.
because losses is very less. If there is a white body or any other material, what will be happen? There will be reflection or transmittance of the light from that material. And we maximum number of the absorption will be not happen means less number of the electron and hole pair will be generated in that case. Then what will happen? There will be less number of the increment of the current will be less. I am correct? Means
Yes.
what happened that like that this is the our conduction band, this is our valence band and this is the Fermi level. I am correct? So when light like that you said that like that this is the material on the surface and there is a diffusion of that materials in basic electron you said how much the diffusion drift current and diffusion current you have to avoid that. Have you heard about the drift current and diffusion current? Are you have you some about idea about what is the drift current and diffusion current? Zabira,
Sir.
what do you mean by the drift current and diffusion current?
Sir.
Like that, the drift current is due to the electric field. Whatever the external electric field we apply, it is the drift current. Okay, means it will provide the path. Now, what is the diffusion current? It automatically generated due to the movement of the electron inside that material, due to the channel, self movement. Okay, and
Okay.
that both current will be generated and like that we have the transistor here. This
Diffusion
is
current.
a transistor and this is the material and electron and hole pair will be from source to drain and it will be collect on the drain side. BGT and MOSFET I think you have to already in your UG program I think you have to learn.
Yes, sir.
So same case in case of the IR detector. We have the two electrode here, two electrode and when light will be falls on these channels here there is a materials the electron and hole pair will move through this channel and it will be collected on one path here electric path and we have to give the current like that this is the my characteristic and like that without exposure my current is like that I think that suppose that 10 nanoampere. Okay,
Okay, sir.
when light will be falls here on the materials here my current will be increased like that. Means electron and hole pair move from the valence band to conduction band and it will be saturated at one place. Okay,
Okay, sir.
and then when again we have to off here light and then it will again come to your baseline same current that. And what is the I think that so suppose that this increment of current is 50 nanoampere here. So difference is we have the increment of the 40 nanoampere difference of the current will be generated due to the absorption of the light on the materials. Okay.
Yes, sir.
Suppose that material which reflected the light or transmitted the light, transmitter through the materials. What happened that there will be some noise will be there in the case, and the sensitivity of the device will be reduced in that case. So IR detector means it will be detect the IR light, infrared light. How much like that we have the silicon diode. Have you heard about the silicon diode?
Yes, sir.
Photodiode, avalanche, Zener photodiode,
Yes, sir.
EPD diode, like that avalanche and Zener photodiode,
Yes, sir.
or pin photodiode, PIN or PIN or PNIN. So what will be happen? We have to biasing the reverse bias. Photodetector will be work in the reverse bias. Like that, this type of characteristic you have to see in that. In the reverse bias, we have to operate the photodetector
Yes, sir.
because we want to collect the electron and hole pair. Hole will be generated here. It will be moved to valence band. Okay.
Yes, sir.
So that's why we have to do the external biasing in that case. That's why the question is correct and answer is correct. Black body means it because we need the maximum number of generation of the electron or hole pair. If the light will be reflected, it means very less number of the electron hole pair will be generated and sensitivity will be less in that case. Understood? Hello?
Yes, sir. Sir, 2 minutes. I guess.
Yes, yes, tell. Yes, you take your time.
Sorry, sir.
If you want to share anything, you can share also me. No problem. We can discuss that also. You can share your skin also.
Sir, actually, where this diffusion current is flowing through, sir, uh,
Yes.
I'm asking that if this process is happening in the black body or sensor, sir.
No, no. Sensor is made of the some materials, not the body. It is a black type of the materials. It is the semiconductor materials.
Yes, sir.
Okay. If the some body is the black color and an insulator, how insulator will generate any electron or hole pair?
No, sir, it couldn't.
Because the band gap is very large. It is
Almost.
above the 5 electron volt. And we have not so much energy that electron will move from the valence band to conduction band.
Conduction.
So
Yes.
it will be about the black body, that black material. That's why that then the surface is the perfectly black body. That surface of the materials. Because what will happen like that? This is the materials like that. And if we have the push the black body, it will be absorb all the light. And what will be happen? It will heat. See that if you wear the black cloth, suppose you wear the black t-shirt, okay,
Totally.
and you sit in the sun,
Okay, sir.
okay, what will be happen?
It's kind of heating, sir. It will be heat.
Heating. And if you wear the white shirt, then white t-shirt,
Compared to black, it would be lighter heat, sir.
so what will that will absorb the more number of the light by the black body. And what will be happen in the black? We need the photo detector. The photo detector work on the principle of the absorption of the light only. Okay, when light will be exposed on any material, that due to the heating also the electron and hole pair will be generated. You can see in the semiconductor material, if we increase the temperatures, the conductivity will be increased.
Yes, sir.
Conductivity that directly proportional to T ki power 2 by 3. A T ki power 2, A T ki power, you read the formula A T ki power 2 by 3 E, that formula, that conductivity formula. Fermi level energy formula, how Fermi energy will be shift with the temperature. Have you remember that things?
Sorry,
That
sir.
Fermi energy equal to that T ki power 2 by 3 KT log Eg bata A, like that formula, that semiconductor formula. In your BTech, you read the semiconductor electronics, that directly proportional to the temperature, that conductivity and that resistance will be inversely proportional. This graph, are you remember this graph? It will be increase and then drastically decrease at T equal to 370 K, that.
Yes, sir. I can remember.
Yes, from that formula. So that's why the because the sensitivity means what do you meaning by the sensitivity?
So the amount of the ability to sense a particle, even it is far away from the sensor, sir.
Yes. Even means minimum energy can be detected by minimum things can be detected by the any devices. Okay.
Yes, sir.
Means how much that if the if suppose that your IR sensor have the intensity of like the 10 microwatt. Okay.
Okay, sir.
And one light will be come around in the nanowatt, right, like 1 nanowatt. If that device will be detect the 1 nanowatt means the sensitivity of the device is very high.
Yes, sir.
Okay, so that's why the question is asked that the sensor has the highest sensitivity when the target means this
Yes, sir.
material, this is the target surface.
Right in front of. Oh, okay, okay, okay.
This 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 is the my target surface. There
Okay,
is a light will be exposed.
okay, sir. So actually, we thought it would be the thing which is laid in front of the sensor, sir.
No, we have to fabricate, we want to detect the IR light.
Okay,
That
sir.
we have to fabricate the sensors which can detect the IR light.
Okay, sir.
Suppose that you know that the light will be harmful for a human being, that UV light, visible light, and IR light.
Yes,
Huh? If our skin will be exposure in the IR light or UV light, you can see that skin cancer will be there.
skin effector, sir.
Yeah, you can see that if you go there is a you will see like that how much that now the skin disease will be happen in the because that due to the ozone hole layer depletion, that directly light will be come to the earth surface, skin will be burned. You can see that now the temperature will be increased. This means that there is a another that detect that not the pure light will become, whole spectrum of the sun will be come to the earth surface. That's why the skin problem will be there. You can see that if we sit in the sun and for 3 to 5 minutes, our skin will be start to burning.
Yes, sir.
Are you feeling like that in that also that?
Okay, sir.
So, if you go through the previous video, our aim of this subject is to we have to fabricate the sensors like that. Not this is the light sensors. We fabricate the gas sensor also. Flame sensor, light sensor, that
Load sensor.
uh, humidity sensors.
Yes, sir.
Okay, like that smoke sensor. If you go through your college and there will be that fire sensor will be installed in your building also. You can
Yes,
see that.
sir.
Huh?
Yes, sir. We have it, sir.
Okay. So what is that sensor? That sensor is made of the some materials, semiconductor materials. If you go through the second, third, and fifth group of the periodic table, there is a mention of some materials that are semiconductor materials. They
Okay.
like that LED is made of the silicon and germanium. If you read in your BTech that what is the material used for the fabrication of the LED lasers, gallium arsenide, you have to read that subject also that.
Yes, sir.
So we use
Typically,
yeah.
typically it is used, sir.
So these materials we use. So that's why that if the material is the black colors materials, okay, we can
Okay.
use that any materials to detect the IR sensor. Like that, me working on the UVC light. You aware about the UVC light?
No, sir.
UVC light have the wavelength of the 100 nanometer to 280 nanometer.
Is it visible, sir?
Not visible. It will not be detected by the eye that even.
Okay, sir.
Okay, and its wavelength is very less means frequency is very high.
Yes, sir.
Means frequency is very high means it will be very harmful. Okay, so what should I do? Like that you had about this formula, you have to EG 1 minute. EG should be greater than equal to 1.24 upon lambda. It is nanometer and it is EV. Have you remember this formula?
Yes, sir. Light.
Like that 1.24 that SC into Q upon lambda, something that this formula, when you multiply SC and Q multiply lambda, this will become around 1.24.
So
and
speed of
that
light.
is the wavelength of the light, and Eg is the band gap
Yes, sir.
energy. So what will be happen that if I use that like that IR light have the, so suppose that 800 nanometer that wavelength. If you divide 1.25 1 to 1.24 by 800 nanometer, what is the Eg value will become? Can you divide? In your mobile, you use the calculator 1.24 by 800.
So 1 mm, sir.
What is?
So 1.5 millivolts.
1.5 electron volt. It will become. Okay.
Yes, sir. Milli electron volts, sir.
Milli. It is already in electron volt. 1.24 by 800.
Yes, sir. 800.
It is it is come around 1.5 electron volt band gap. Okay.
Okay, sir.
So it is band gap value. So the material is like that material like silicon. Silicon have the band gap. What is the band gap value of silicon? 1.1
5 electron.
volt silicon. Germanium is zero point 0.8. Easy value, you remember that silicon on room temperature and that 1.1 and 1.2 electron volt.
So
It,
0.65 germanium.
yes. So this easy value means your this Eg should be greater than this, like that it should be 1.5 electron volt. So material which have the band gap value of the greater than 1.5 value, it will be detect the IR light.
Okay.
Okay. So we calculate that means is if we use the 900 nanometer, 1000 nano and 1000 nanometers, so what will have the Eg value will be increasing in that case because it is inversely proportional. So we choose the materials like that MOS2, like MOS2 is the 2D material, molybdenum and sulfurization we have to do like the MOS2 that have the band gap around 1.3 to 1.9 electron volt, and it will become in the range of the 1.5 electron volt. So we can use the MOS2 to detect the IR light. Like that in my case I use the gallium oxide, that wide band gap that have the band gap of around 4.1 electron volt to 4.9 electron volt. Okay. So from this we decide a detector, okay, which material we use for light to maximum absorption. So we have to choose that material for absorption. That's why they have said that if the material have the black color,
Yes, sir.
which they have give the maximum absorption in that case for IR case. So if you type in the Google, some paper will become that research paper, IR sensors and like that. Black body is sensitive. Like that, I have one paper open that now. In that case, I will show you 1 minute. If you do Google, see that this paper you can see. See that they have prepared the black body sensitive room temperature infrared photography based on the low dimensional tellurium grown by tellurium. They use the material tellurium, TE material, and see that this is the introduction. They have the result like these materials. These type of the material we have to deposit. Some technique will be used for deposition. We have to evaporate the material either thermal, PCVD, LPCVD, MOCVD, ALD. These are the machine that equipment used to deposit some materials that on that. So maybe if you are interested in the MTech in the nanoscience and nanotechnology, then you read this more about theoretically that about that this machine about that after BTech or if the PhD.
Okay.
So see that this is the growth that this is the machine they have to fit this. They use that the SNT to hear that material and this SI to see that they have fabricated and see this is the result. This is the IV. They have to make that you can see that gold color electrode. One minute. See that how devices is fabricated. Uh, see, have you this diagram visible?
Yes, sir.
See that this is a silicon on that they have deposit dioxide layer. This is a titanium that they use the electrode, gold electrode.
Yes, sir.
And this is the IV they have that VGS means gate to source voltage 0 volt, but they have not apply any potential, self bias. And see that this is the sensitivity of the light wavelength. See that 500 nanometer to 250 nanometer, and it will be the maximum value at around 1500 nanometer. See, and 1500 nanometer is the IR light, far IR. 1550 nanometers. See that this is the graph photo current, how the current will be increasing and that. Understand?
Yes, sir. I can understand, sir.
That's why the questions is right that they use that black body is more sensitive for the IR case that one because their band gap is in approximately the same range that.
So then I would say the sensor has the highest sensitivity when the target surface has more absorbance than reflectance. Am I right, sir?
More, not reflectance, mode absorption. Reflectance we don't require that.
Yes, sir. More absorbance than reflectance.
Yes, absorption because sensor will be absorb that light. When the absorption will be happen, then in that case that more number of the electron and hole pair will be generated
Yes, sir.
because we require to generate the holes and electrons. Otherwise, current will be not increase in that case. Okay.
Okay, sir.
Any other doubt?
No, sir. You can start the session now, sir.
So can you answer me these things if you read that these two questions? Can you try?
Sure, sir. Mask aligner is used in lithography. Second one, sir, it's align mask and wafer
Okay.
and expose the coated photoresistant wafer, sir.
Okay. So have you what is the mask aligner?
Sir, it is.
Uh, uh, so what is that coat photoresist on vapor? What is the meaning of that? These that develop a
Sir,
pattern
it
and
is photoresist is an sir, it is a
yes,
substrate.
yes, I will correct it. You can answer that, no problem. Whatever you know, you can answer. Then I will correct it if anything is missing.
Sir, it is a material, sir, that is used to patterning, sir. Used for patterning what we want to
So
apply in the
this
substrate or
case this case is also same that your previous question. Like that we have to choose the materials which
yes,
can pattern in the case of the UV light. We have to pattern in case of the UV or X-ray light.
UV.
Okay? Yeah.
Okay.
Like that these are the design. You have make one design. Okay? Like that you have to make this design. This design you want to transfer on these materials, this silicon paper. Okay?
Okay, sir.
So this design you have to make and printed on some glass substrate, glass. Okay,
Yes.
there is one mask is coming that this design already printed on some materials, glass, copper or something that. Okay,
Okay, sir.
then what you are in the lithography you put this substrate and then spin coat the some photoresist. Either it is two type either positive or negative depend upon your applications.
Yes, sir.
When you spin coat this photoresist and then what will happen this UV light will be exposed on this pattern you have to align that pattern.
So
Okay,
is it positive? Yes, sir.
yes, tell me.
So is it positive or negative, sir? What we are using?
It's depend upon applications. Positive photoresist will be the pattern will be, the remaining part will be not exposed, like
Yes,
that
sir.
photoresist. Like that, this is the I will explain in the next slide also. I have systematic like that. This pattern will be transferred like that. Okay.
Yes,
So in case of the positive means this type of the light will be exposed here. Okay.
yes,
So
sir.
what will happen? This type of the pattern will be formed in that case of the positive. In case of a negative, if light will be exposed here, okay, and this is the pattern form, and this will be removed, and
Yes,
there will be electrode, this photoresist, the remaining part will be removed that.
yes, sir.
Okay. So it's depend upon your applications that you can use the positive and negative. In case of the lift off process, some people use the negative photoresist.
Yes,
Lift
sir.
off means you want to lift off the some pattern on through the upper surface that. I will explain that in the next slide everything.
Okay,
So
sir.
next question, what is?
So, so mask aligner is mainly used for aligning the mask
Yes,
and
yes, yes.
such.
This pattern. There is some aligner. There is some align element. So mask aligner means we have to align. You have to print some design on that, some material that.
Yes, sir.
What is next question?
So next means
These questions.
uh, so first one is spin coat, sir, photoresist.
Okay.
Second is is a spin coat photoresistor, then soft bake, then mask loading and exposure, then developing, and then hard bake, then etching and stripping photoresist.
So what do you mean by that soft bake and hard bake?
So soft baking means it's 90 degrees Celsius. Um, sir, it
Why
is
we need a
90
soft
degrees.
bake and hard bake? We were heat to temperature that after that spin coat the photoresist.
So hard bake is mainly used for hardening the silicon wafer. Soft bake is, mm, I reckon, it is used for the adhesive property or chemical and thermal properties.
So like that photoresist will be in the form of the liquid. Okay.
Yeah.
When we spin coat like that, this is the spin coater, it will be move some rpm, that is speed, and it will be, we have to drop cast. This is the drop, we have to take some pipette here like that, dropper like that, we have to collect some that, and we have to drop cast on some material like that, it will move. Okay.
Okay, sir.
It will move and we have to drop cast here, so it will remain in the liquid form. Okay.
Okay, sir.
What we have to do some on 50 degree 60 degree we have to bake, and it will we make it the in a hard form. Okay. That
Okay.
liquid portion will be evaporate in the some 850 degree 60 degree 90 degree, and it will be hard. Okay.
Yes, sir.
And then we have to put the wafer in the that mask aligner lithography. Okay. And then we have to expose, and then we have to, when we have to do etching and anything, we have to do the hard baking of that materials, because we want to remain that their photoresist on there. Otherwise that pattern will be also move that, and we
Yes, sir.
waste that materials. Okay. So
Okay.
during the developing process we have to do the hard baking. Understood?
Yes, sir.
So next question, in the fabrication process, acetone dip is done to remove what?
It is photoresist stripping, sir.
Okay, yes, because whatever the remaining acetone will be there after that exposing, because we do not want that photoresist, because it is the inconductive, and it will be uh, because not expose that proper our that materials, that it will be one layer on above our materials. Okay. So active area of the device will be reduced if there will be any photoresist will be there. So we want to remove unwanted photoresist. So we do the etching in presence of the acetone. Okay.
Okay, sir.
We will put our material for the 30-second or 10-second on depend upon that period of timing that when will be completely remove. So what is the resolution of the 8-bit ADC working at the reference voltage of 3 volt?
Sir, I have calculated this by using the formula 3 divided by 2 to the power of 8, sir. V reference. Okay,
You
minus.
use this formula? Have you in digital you have remember this formula in digital electronics?
Resolution.
ADC
Yes,
and
sir.
DAC.
ADC and DAC converters.
Yes. So V reference you have to already given and N you given to 8 bit. When you divide 3 by 2 ki power 8 minus 1 means 3 by 2 ki
255,
power
sir.
8 means 2 5 and
255.
256 means 255.
Yes,
Then
sir.
what will it become?
So it's 11.6.
11.72.
Yes, sir.
So answer correct answer will be
Yes, sir.
your will be same.
So 0.0, yes, sir. 1 point, no, sir, 11.76.
In what is your answer in that case? You submitted already
This is
this quiz.
what, yes, sir. This is what my answer is also.
Huh?
Yes, sir. This is what my answer also.
So you answer this your it is correct or you have to do wrong in that case?
Yes, sir. It's right, sir.
It's right na? So
Yes,
how can you solve without that formula?
sir. Actually, I have used the previous year's question, sir.
So
That
you
is,
just copy paste.
no, yes, sir.
Huh?
No, sir. Yes, sir. I copied the method they used.
You just paste the question in the net and you got the answers.
Yes.
Huh? Google.
No, sir.
Yes, yes. Huh? So how is the biosafety
Who?
fume hood disinfected?
So UV sterilization,
What is the other sterilization? Why we use the UV?
sir.
Why we use the UV? Why cannot we use the temperature, steam, air thrust? Have you seen the fume mode in the video or anywhere?
No, sir. UV sterilization is. I
Where
saw
you
it is used in swimming pool cleaning, sir.
swimming?
Swimming pool and laboratories.
Why we use the UV light?
I don't know, sir.
Huh?
No idea, sir.
So you heard about the name COVID?
Yes, sir.
You aware about the COVID?
Yes, sir.
You because you also the COVID patient?
No, sir. But I'm in the world of COVID, sir.
Huh?
Sir, I
In
was in the
anywhere?
time of period of COVID, sir.
So you face the COVID?
No, sir. Not
I
yet.
mean, you are the safe, huh?
Yes, sir. I was safe.
So, why COVID? What is the COVID? COVID is like one bacteria,
It's a virus, sir.
virus. So how will you diffuse that virus and to dead that virus? What people theory in that case when the COVID will become? Have you
Sir,
heard the newspaper and many news that if the temperature will be high, that COVID virus will be not, it will be dead and it will be not remain in the air. You always inhale the hot water. You take the steam in the hot.
you
Huh?
should be isolated.
Not isolated in. If you want, if your virus will be in the throat, you have to inhale the hot water. Drink the hot water.
Is it so, sir?
Huh?
Actually, my area was safe, sir.
No, no, area is safe. That people are like that. Doctor will advise that you do not eat the cold things. Cold, you not remain in the AC. Huh?
Yes, sir.
So you that to dead that virus or bacteria, We like that we use the UV light. UV light will be dead that virus. Okay.
Okay,
So
sir.
what will be yeah?
Okay, sir.
Huh?
I
You
said
understand?
okay.
That's why the UV is harmful for human being. That's why I
Yes, sir.
told you that UV light. Yeah.
Yes, sir. It is harmful for us, sir.
Yes. That's why. That's because that it will dead the some tissue and that skin tissue, some
Skin is.
bacteria and virus. That's why people that when you go to the X-ray room, there will be some dangers. You have written that things that when you enter in the X-ray room, have you done any X-ray in your life?
Yes,
Your
sir.
body. They have that they have the cross mark and it will be high gray and everything. We have not to expose many times in the X-ray. People, doctor are advised that
Yes, sir.
various, various.
It may be caused cancers also, sir.
Yes, yes. That's why. So that's why because in the fume mode we have to working that. You can see that I will show you. Uh, like that. I will 1 minute. Uh, how can I move to camera? See, this is the fume mode. This is the fume mode. You see that?
Yes, sir.
This is the fume mode. So this is that panel that electrically opening and that switch and then these are material we have to hold in the fume mode. So this is the shutter and here is a blower that air will be blowing upper. Uh,
Yes, sir.
when we have to start it. So this is the fume mode and we have to put the sensitive material here. And when we have to working that some material exposure, we have to use your hand only gloves. We have to wear the gloves. These are the gloves we have to wear and then we have to operate here. Okay. So
Okay,
there
sir.
is a light that this is a light that they have to UV light this sterilization, tube light, and we have to dead all the bacteria and impurity present in that case. That's why we use the UV sterilization.
Okay, sir.
Okay.
Why
We
not we
can
use
use
temperature
the
sterilization,
yeah
sir?
yeah.
Why can't we use temperature sterilization, sir?
If the it will be depend upon the applications
Okay.
because some bacteria will be very harmful. They will be not they will be sustained at even high temperature also.
Yeah, yes, sir.
But in case of the UV, it will be impossible to remain in that case.
Okay, sir.
So what will be the whatever the instrument and equipment they use in the COVID, they make the UVC light chamber and in UVC light they sterilize all the equipment what a doctor use in that case. Okay,
Okay, sir.
so that's why. What is you meaning that clean room classroom?
So it's the
Just
number of particles per cubic feet allowed inside the facility, sir.
so how to identify the particle size? If you go through my video that I have uploaded on YouTube, I explain about the clean room that one class.
Okay, sir.
Clean room class that 1,000 class, 10,000 class, 100 class. So size of the particle means that 10 micrometer to 10 nanometer, 1 micrometer to 10 micrometer that present in the room air that room. Okay. So what will happen that type of the particle will be removed. That type of particle even not present in that room. That's why that is the clean room. Okay. So
Okay, sir.
that number of the particle per cubic feet allowed inside the facility means this type of means if the 10,000 class clean room will be there, then means 10,000 particle size will be if the particle size will be 10,000 micrometer, okay, or 10 micrometers. in per cubic feet, that will be allowed, that will be safe. If more than this will be happen, then it will be how it will be change the property of your sensor or device that you have to fabricate it, make. So we want to remove unwanted impurity, surface impurity from that particle size, and our surface will be removed in the pure form. Then we all the work will be done in the clean room and the fume mode. That's why the fume mode is important part for the fabrication facility. Okay.
Okay, sir.
So what is next questions? The correct statement, which is the correct? Parnav, Suthar, are you there? Parnav? Parnav, Suthar, is
Yes, sir.
what you can you answer these questions? Can you try?
Mm-hmm. Uh, is it option A, sir?
Smallest image that can be projected on vapors. Okay, A is right. Why A?
Uh, because photoresist is like playing on the substrate, right? So the smallest feature is the smallest image projected on the wafer.
What is the smallest size that you can understand that? In the micrometer, centimeter, or nanometer, what size?
It's nanometer. So far in the 5 nanometer chip, so it's in nanometer size, right? Applying the photoresist.
If you want to expose that 5 nanometer device want to manufacture, which type of lithography you use in that case?
So for that we use EUV lithography. Is from ASML.
Okay, UV. So, are you PhD student?
No, sir. I'm undergraduate.
Which college?
Ishwar College of Engineering in Tamil Nadu.
Okay, Tamil Nadu. So
So
you
we
are
are in the same college, sir.
you are both
Yeah,
on
we are
campus.
friends, sir.
Okay, okay. So you have a facility in your lab that in your college like that, this fabrication
No,
facility.
No,
we
sir.
don't. No, we don't have MEMS, sir, in our college.
Okay, okay. Are you visited in any IT? You have chances?
What, sir? Any?
IIT Madras or NIT Tiruchirappalli you have visited?
No,
No,
sir.
sir. But I
We are
wanted to go
trying,
to
sir.
IIT.
No, no. Any fest or you have to go that any time for project work or anything? Your
No, sir.
professor.
No, we haven't.
Okay, okay, okay. So when you have time, you can visit it at NIT Tiruchirappalli have also facility of that fabrications.
Yes, sir.
Sure,
Yes,
sir.
sure, sir.
Maybe it is nearby you. Maybe NIT Tiruchirappalli.
Yes,
It is
sir.
nearby or far?
We will visit, sir.
No, no. How much the distance with the NIT Tiruchirappalli and your place?
Around 300 kilometers.
And IIT Madras?
Around 500 kilometers.
Oh,
600, sir.
Yeah, 500 or
IIT Madras has a good facility.
Yes, sir. Yes, sir.
Okay. So the smallest feature means that smallest image and resolving capability of the photoresist. That what are the controlled by the lithography means how much what a type of the photoresist used to printed that materials. Okay, so both the statement temperature of the vapor will be not we have to in the control. Energy of the ion implantation is the different things. Okay, these both are the different things. In the photolithography, we have used these both things that.
Yes, sir.
Okay, ion implantation is a different things. It will be used for the adding of the impurity in the air material implantations. Like that, you heard about the extrinsic semiconductor and intrinsic semiconductor.
Yes,
Are you
sir.
aware about that?
Yes, sir. We studied extrinsic and
So,
doping the
will we,
semiconductor.
yes. So for doping, we use the energy ion implantation beam.
Oh, yes, sir.
Okay, or for
Yes.
temperature of the vapor means you can heat the vapor around 50 degrees Celsius, 100 degrees Celsius as per your requirement. But it will be not play in the role of the photolithography.
Yes, sir.
Yes,
Okay.
sir.
So now we have to continue that basic concept. Some I maybe if you have any doubt, you can read and ask me. You can interrupt in between that.
Sir,
Okay,
before that, what is additive manufacturing? Additive microfabrication?
additive,
Additive microfabrication.
additive.
Yeah, in one of the assignments, they said sputtering is not an additive microfabrication. So that's why.
Splitting is for deposition of the material.
Yeah, deposition of material, whether it is additive microfabrication, sir.
Additive means like that splitting. We cannot use any material for the deposition. Means any other material. Like that, I have deposited a thin film through the splitting like that Zereno. Okay, zinc oxide.
Okay,
Okay, this is the Zereno layer. Okay, this
okay,
we cannot use the any other some interference material or some supporting material to deposit on that this silicon vapor. Okay, like
okay,
that.
sir.
Now we want to transfer this Jadeno layer on other material, like that this other substrate, like the glass substrate I have, and I want to transfer this thin film on this. Okay,
Yes, sir. Yes, sir.
what will we do in that case? I use the that case that we use the PDMS or PMMA. Okay, some
Yes, sir.
other material that will be soluble in that case, and I will spin coat on this PMMA layer on this layer.
Mm-hmm.
Okay,
Okay,
means this is the adhesive now. Okay, what will happen now? I want to remove this silicon layer and to separate on these both things. This will be additive and this will be removed silicon layer here. So I use the one chaos solution. Okay,
okay, sir.
some solution that will be remove that silicon from that layer, and this will be additive in the PDMS. It will be stuck in the PDMS layer. Okay,
Okay,
now,
sir.
after the 3 to 4 hours, this silicon will be separated, and this layer will be flow on that chaos solution. It will be float on that surface of that chaos in the soluble, some beaker, white layer. Now I will like that. This is a tweezer. Okay,
Okay,
this is a
sir.
tweezer. So I hold that layer through the tweezer and paste on that this layer on that material.
Yes,
Okay,
sir.
and
Yes.
I will heat around 50 to 70 degrees Celsius, because it is in the soluble and it has some water particles in that, and I want to dry this layer, and then I will place some stuck on that materials other layer. Okay, so what will happen, this Jadeno layer will be stuck with the PMA and it will be transferred to the other materials. So that will be adhesive process. Means through the some addition material we use to transfer some layer to other pairs, the other materials.
Yes, sir.
So that is the adhesive MEMS.
Yes, sir. Yes, sir.
Okay, sir.
Okay. Any other questions?
Sir, in week 7, actually, there is a question regarding the IR sensor sensitivity.
Yes.
I think the solution for that uh, question is wrong, sir.
No, no, it is right, man.
Sir,
It is right.
Yes, sir.
What is
I'll tell them, sir.
what is the IR means?
infrared
And what is the sensor meaning?
uh, to obtain the output.
What definition of sensor? Can you explain the definition of the sensor?
To sense some quantity and to
To do
convert it
some
as
physical
an
quantity, some
electrical or
physical stimuluses.
what,
Okay.
sir? Yes,
Some
sir.
physical quantity can be sensed by any sensor. Okay.
Okay.
And it will be it will be given in the form of the electrical or some mechanical. If you want which form you want to convert, you can take that form through the
Okay.
transducer and that actuator.
Okay, sir.
So you want to sense the IR light.
Yes, sir.
Okay,
Yes, sir.
and they said that maximum absorption in case of that
Maximum absorption, black body when
black
we
body.
place.
So if maximum absorption is maximum current will be generated in that case.
Oh, yes, sir.
Okay.
Mm-hmm.
So what will happen in that case? So who will be more sensitive? Maximum absorption is in the black body or white body?
Why black body?
So that means there is a more current in the black body or white body in the case of the reflectance and transmittance.
More current in the black body.
It means more sensitive who is.
So black body is more sensitive.
So how it is wrong?
Oh, okay, sir. Okay, sir.
How it is wrong? See
Oh,
that if you read a Snell's law,
yes,
okay,
sir.
my light will be false here.
Yes,
Okay,
sir.
one is the reflectance and one is reflected.
Mm, sir.
One is the reflection and one is refraction.
Yes, sir. Yes, sir.
We do not want the reflection. Reflect. We minimize the reflected. This is the disadvantage because maximum energy will be not transferred. It will be come again through the air.
Yes, sir.
It is loss.
Yes, sir. Since it is
Yes.
a black body, it completely absorbs.
Okay.
Yes, sir. Yes, sir. Understand.
That's why you are thinking in the way that because IR means that we want to detect the IR light. We have to manufacture or develop the sensors which can detect the IR light. Like that, use the remote. Have you used the remote, TV remote?
Yes, sir. TV remote.
Which light will use you for that in that case?
Yes, sensor.
IR sensor. Means
Yes, sir.
you have the IR LED
Yes, sir.
in the remote, and there is a one detector in the TV that will detect that light signal.
Yes, sir.
Yes, sir. It will be in black color, sir.
Yeah,
It's in black color, sir.
depend upon that material we have to use because now the market that people are working research on that different material for fabrication of the sensors. Okay. Previously, that in case of the conventional, we use the silicon and germanium, gallium arsenide, and that sensor will be used in that case. Then, now people are moving on that 2D material, 1D quantum dots. The people are making the nano rods, nano wires, because the sensors response depend upon the active area exposed. How much the active site will be there. Okay, means
Yes, sir.
people are working that number of the electron and hole pair will be generated more in case of the less light will be in come on that case. Have you did a digital communication,
No, sir.
analog communication?
No, sir.
In your BTech you have not teach that analog and digital communication.
So we are from electrical and electronics.
So optical fiber subject.
We don't have this.
Basic semiconductor electronics. Photodiode you read, APD photodiode, AMLED photodiode.
Yes, sir. We had learned semiconductor physics.
So that is the basic that is the basic that things that the other devices that is the basic principle that even working that how the Zener diphotodiode will be work in the reverse bias that electron multiplication will be take place when the some electron or some light will be false or some we have to base the biasing on that case. We have to form the channels only. Complete the circuit that case.
Yes, sir.
Same case we have to use the materials which can sense the light. Sense means the more number of the absorption in that case.
Yes, sir.
Uh,
To
if
generate
you
more current.
if you read that in the optical fiber, if you have any subject, if you have chances in the for final year, third year, okay.
Okay,
Yes,
sir.
sir.
If you have the elective subject, then you see how the optical fiber will be work in that case. You have the more understanding that what material the silicon total internal reflection will be done. There is a detector which can detect that light, how much the pulses that are generated, and if you go to the YouTube video, that you have to also find that YouTube video.
Yes.
Okay.
Sure, sir.
Sir.
So photolithography is a Latin word. ठीक है ना? That means light stone writing. So if you visited some temples and historical palaces, people are transferring their art on the stone. Have you, in the south there? I think there are a lot of the temples. They have the design on their temples, names,
sir.
and they have printing
Sir.
some designs on that stone.
Yes, sir. They just engrave.
This is engraved. Okay, like that we have to engrave that design on our materials. We
Okay.
want the same pattern to transfer that. If they have the using the hand to transfer their design. Okay, but we want a special design because their size is very big, but our size will be very small. Even we cannot detect through our eye. In nanometer, you can see the nanometer devices. Jabira,
Sir?
you can see through your naked eye the nanometer
No, sir.
size of particles.
Too tiny, sir.
So that's why we use the machine to fabricate a nanometer size.
Yes, sir.
Yes,
Okay.
sir.
So photolithography is the same as that they have the transfer the light stone writing on that case. We want to transfer some like that. We go to the studio and the studio will be click our photo and he will be transferred on the paper.
Yes, sir. It's Polaroid.
Same case we have to transfer our design on our devices. That sensor.
Yes, sir.
Okay. So photolithography is an optical means of a transferring of pattern onto the substrate. Means optical source we use, like UV light, X-ray light, visible light. We can use that optical source. Okay.
Okay,
So
sir.
like that Sudha told me that EUV, EBL, electron beam lithography. Okay. That technology that depend upon our design. We use the depend of the machine and light. That I will be explain that what source of the light will be used. So this is it is the initial the same process that using the lithography pattern. So photoresist is a liquid film that can be spread out on the substrate, exposed with the desired pattern and developed. So we use the photoresist to transfer that our devices. Okay.
Okay, sir.
So this is the same that number of the lithography stage device, that wavelength, that type of radiation, and what of the wavelength of light we use to transfer that smallest feature on that our devices. So this is the basic lithography example. This is this see that
Materials
this is
used.
the film. This is the substrate. Then we have used the photoresist. This is the black color, and this is the mask. Okay.
Yes, sir.
Yes, sir.
So what is this white light? This is the design. Okay.
Okay, sir.
Yes,
And this
sir.
is the not a design. This is the blank. So what will happen? This design. See that. This design will be exposed and this photoresist will be remaining.
Yes,
Then
sir.
we have to etch this silicon that material layer and then we have to etch this resist that remaining photoresist
Yes,
through
sir.
the acetone.
Acetone.
Yes, sir.
Okay.
Okay, sir.
Or
Yes,
different,
sir.
like that we want to like that we use the gold or silver or chrome or metal that we use, so we have to use the different agent which can remove the gold silicon. So as per the application we choose the agent available in the market, or we have to
Yes,
develop
sir.
ourselves by mixing some hydrochloric acid or acetone, IPA and other material. We can mix that solution and make our solution also to develop
Yes,
that
sir.
design. So this is the positive and negative
Negative.
photoresist difference.
Okay, sir.
Zabira,
Sir.
you can see that.
Yes, sir.
So what will be
Yes,
our
sir.
this will be remaining the positive, but in case of positive, this will be remaining.
Sir, it's island and whole type, sir.
Yes, like that. This
Especially
seed
bright field mask.
we have to expose. Okay.
Yes,
So
sir.
what will happen in case of positive? In negative, it will be removed. Only this will be remaining. But in case of the positive, this will be remain and this will be removed.
Yes, sir.
Opposite. We have to do the opposite. So we want to like that this will be safe. Like if we want to deposit some material on like that we have deposit gold here. So whole gold will be deposited here, and there will be remaining safe these things.
Yes, sir.
And then after deposit gold, we can remove this positive photoresist.
By acetate dip.
Okay.
Okay, sir.
Yes, sir. Yes, sir.
So this is the like that this circuit we have to make fabricated this circuit through the lithography. This source, drain, gate, and electrode we have to deposit through the lithography. This transistor. So this is the process sequence in the lithography. So surface of the silicon wafer has been oxidized form to the film SiO2 because we need the insulator. So SiO2 is the insulator.
Oxide layer.
Yeah.
Yes, sir.
So we have to deposit insulator. It is desired to remove the SiO2 film in the certain region as defined by the mask. So where we do not want to SiO2, we can remove through the etchant. Okay, like KOH solution is you remove to SiO2. Sequence for the negative resist proceed as follow. Same for the EA. See that we have to deposit this SiO2 layer here. Silicon above that SiO2. This is the SiO2 layer. Then we deposit this resist here,
Photoresist.
photoresist, and then soft bake.
UV light exposures.
Means soft baking. We do the baking at 90 degrees Celsius,
Bake.
as you previously said, Gabira.
Yes, sir.
Okay. Then we do that pattern of the mask here. UV radiation. We use the UV light. Maybe 365 nanometer, 395, 350 nanometer, whatever that available, that light lamp. Okay.
Okay, sir.
And then this mask, this pattern will be that pattern here, that expose. See that in case that for 1 minute, for negative resist, unexposed area are dissolved.
Dissolved.
Okay, but in case of the positive,
An exposed area will be stronger.
dissolved. Okay. See, this is the hard bake. After that, we have to done everything. We do the hard bake for dissolution, dissolved for that. Okay. And then
Yes,
we have
sir.
to add then we have to add the SiO2 layer. See that
So
is
we have
SiO2.
to develop the photoresist, no, sir.
Yes, for develop that.
For hard baking.
Developing solution and increase the addition of the resist. To addition of this resist. This
Okay.
remain. This is the photoresist remain, na? This photoresist.
Yes, sir.
So to make, because it will be react with the light also, UV light,
Yes,
and
sir.
so it will be maybe soft in that case because UV light will be break that material.
Okay,
Okay.
sir.
So what if we not do the hard bake? It will be removed in the solution also that. So we do not want to remove this. We want to remove this at the last step. Okay.
Okay.
Before that we want to remove this window, this silicon oxide layer.
Yes, sir.
So it will be removed through the etchant. See that?
Okay,
Okay.
sir.
And then resist coating. Then we have to remove this resist. Otherwise, what will happen if there will be not resist, that when we do the etching, it will be also removed, this oxide,
Yes.
whole oxide. So we do the hard baking in that case also. Understood?
Yes, sir. Sir, I have a doubt, sir.
Yes, tell me.
Does annealing take a part in photolithography?
What? Can you
Annealing,
pattern?
sir.
Annealing.
Yes, sir.
So hard baking is same as the annealing. This is the same. The people are using hard bake, means we do the annealing that.
Sir, okay, sir.
Means annealing and hard bake, means hard bake is the name just, but we can use annealing. We use that in some other process during the material deposition. We do the annealing, name the annealing. But in case of the lithography, we say that is the hard bake and soft bake. But we
Okay.
use in the temperature, presence of the temperature only.
Yes,
Okay.
sir.
Okay, we have the one hot plate, like that one instrument. There is a thermocouple, thermometer, that hotting plate. We increase the temperature, digital, that may be digital or analog, and we set the temperature around 100 degree, 300, 400 degrees Celsius.
Yes, sir.
And we put our substrate on that plate, and we keep around 10
After
to
that,
20 minutes.
yes, sir. We used
So
to keep it
in case of that lithography term, we can get hard bake and soft bake, and people also that we do the annealing also. you can say both the name are same, that both things are the same,
Okay, sir.
not any difference. But annealing can we do in the presence of the gas also. That nitrogen, oxygen, argon in the presence of that gases.
Okay, sir.
Okay. So people are saying that we do the annealing in the presence of the nitrogen, in the oxygen, argon, or the inert environment. People are using the word like that.
Okay, sir.
But what annealing they increase the temperature that in presence of the temperature only. Okay.
Okay, sir.
Anything else?
Sir, in the case of SU8, there was saying that before hard baking, sorry, sir, the photoresist development is only processed after the hard baking, sir.
Photoresist ascent will be after the hard bake.
SU8, sir. The flow will change in the hard bake and the development, sir. PR development in SU8
Developer
photoresist.
we have to develop the first we have to do hard bake and then we have to develop.
Yes, sir.
Not first not to develop.
In
Okay.
both the cases or in SU8 only, sir?
It depends upon the property of the photoresist. SU8 is the type of the photoresist.
Yes, sir.
There is also one photoresist PMMA. This is the organic photoresist.
Okay, sir.
Okay. So there is a lot of the photoresist available in the market. There is negative photoresist are different, positive photoresist type is different. So it's the property of that photoresist. The company will be provide a specification. If you use this photoresist, you have to follow this process. Okay.
Okay, sir.
So it is the property of that photoresist only, not that sequence will be, because whatever the material we use, we can do change the sequence also that according to what type of material or photoresist we have used.
Okay, sir.
So we have to, because we have to give the specification. If we buy something, we provide a specification to company. Okay, and
Okay.
according to that we have to use the red material, handle red material. Like that silicon have the like that you are not attending my previous lectures. I have explained that type of the silicon orientations. So silicon is 100 type, 11 plane types, 110 types, 111 types plane. How to identify that is the N type vapor or P type vapor, P type silicon or N type silicons. I explain everything in my last video. If you subscribe my channels that on the YouTube that or I have shared that also, that seed that also that.
Okay, sir.
I have explained about that silicon vapor. So it's depend upon what type of silicon you have used that. Also that orientation that depend upon that. That will
Channel
be
name?
also, yeah.
Channel name, sir?
You can my channel name is Ashok Kumar, that P19W203.
Okay, sir.
Okay. If you click that YouTube link, that you can go through that my channel only, that there YouTube channel.
Okay, sir.
So I explain everything that around the 64 slide will be there, everything that. Last time no one will be joined that class my. Even I am happy that you are two people are joining this time.
Yes, sir. We
Yeah.
had a blur in our minds, sir, about tire sensor, sir.
That's why you join that class. Maybe next
Yes,
class
sir.
you may be in that class.
The course is also interesting, sir. So
Yes,
that's why.
sir. It's
Yeah.
kind of research oriented, sir. This course.
Yeah.
Yes,
This is
sir.
the research oriented. This is only the research oriented.
So we are so admired this course, sir.
Because this is the only that this is the fabrication real devices. How that people are fabricating the ships.
Yes,
If
sir.
if
Yes,
you
sir.
visited, if you have you that if the CMOS technology, CMOS is also fabricated from this same type. This photoresist and everything CMOS source, drain and gate, everything fabricated through this process only. We use the silicon layer, okay? We make that P channel and N channel. We deposit SiO2. We have to develop gate. Here we have to develop source and drain. This is all the process that use the photolithography. Same process. We open the channels here through the photolithography. Same things we have to do here. So if you
Yes,
want
sir.
to fabricate a BGT and diode, we use that photolithography. Okay.
Yes, sir. Yes, sir.
So real time that people are like that. You say that Intel have a technology of 3 nanometer, 5 nanometer, 7 nanometer technology. Have you heard
Yes,
that?
sir. Yes,
I have
sir.
explained in
Quite.
my lecture 2 or first in a YouTube video. I have explained that what is the technology, what is the
Yes,
meaning
sir.
of the
The
technology node.
technology notes, right? The
Yeah, how the
mm,
technology mode will be changed. What is the scaling that now the people are using the scaling for defining a technology node.
Yes, sir.
People are using that 22 nanometer technology, CMOS technology, but they have the scaling that device with the divide by the some S, and they name that is a 3 nanometer node, technology node, 7 nanometer, 5 nanometer. But actual size of the channel is the 22 nanometer only.
yes, sir.
Okay.
Yes, sir. Yes, sir.
They not define the size of the channel of that from source to drain, that between the size of channel is the 22 nanometer actually.
Yes, sir.
Even I have to work in the Intel for the 1 year that for design of that processor that also that.
You work for Intel.
Yeah. Even I have to work on the 10 nanometer technology node, 14 nanometer also that.
Yes, sir. Sir, before that, we got some doubts, sir. So, can I share my screen?
Yeah, yeah, sure, sure. Should I stop?
Oh, yes, sir.
Sir.
1 minute. I stop my sharing. Yes, your screen is visible. Tell me.
So here, I have a doubt, sir. In SU8
Yes.
fabrication, sir. Here, after soft bake, they used hard bake, sir. What does that mean, sir?
Like that there.
He had explained something, sir, but I couldn't figure it out, sir. The difference between just like that general positive and negative photoresist and with the SU8, sir.
Okay. So after that soft bake, they immediately do the hard bake.
Yes,
Yes,
sir.
sir.
So where you have to taken this?
So it's
Sir,
from our lecture video, sir.
lecture video, sir.
Lectures video.
Yes, sir. Week
It's in
4
week 4.
seems.
NPTEL.
Yes, sir.
Yes, sir.
In our
Week
course,
4.
sir.
Yes, sir.
Week 4.
Let me show the lecture number, sir.
Week 4.
In week 4, it is lecture number 2.
Week 4 or week 2?
Week
Week
4,
4.
sir.
Okay, week 4. It is basic patterning and drug scanning devices. In that,
Yes, sir. Yes, sir.
Yes, sir.
1 minute.
There he showed the SU8 pillars forming, sir, like screening,
For drug screening.
drug screening, sir.
For what?
For
Drug screening.
for making the well, sir, around
Oh,
Intel
well,
Digital.
okay, understand that. Understand that. 1 minute.
Next one, photoresist developer. Next, hard bake,
My net is not working.
right? So this is the photoresist.
Maybe I have included in this slide also SU8 or that. Can you stop that? Maybe in my slide will be there.
Okay, sir.
Okay,
Okay.
sir. I will stop.
Okay, yeah, you will stop that. Maybe in my slide will be there also that. Uh, I have maybe explain that photoresist also first that. Mm, 1 minute. See that. This is a negative photo registry, positive, negative, H back. Backing process, this is lift off. Alignment.
இருங்கம்மா.
Booking technology. This is SU8. This is. Is it visible?
Yes, sir. Yes, sir.
Yes,
Visible.
sir, visible, sir.
So this is the structure of the SU8 structure. Okay.
Yes,
And
sir.
QoS, this is soluble.
Sir, in SU8, after soft bake, you directly go to hard bake, right?
Yes. But why? 1 minute. I provide a reason that why they are using. Maybe I have explained about the soft bake and last bake in the 4th class also week.
Okay, sir.
Yes, sir.
Can I ask you a question, sir?
Yes.
Sir, so there are three components, basic components of photoresist, sir.
Yes.
They are resin and sensitizer, and one more is
One more
solvent.
is
Solvent.
yes.
So, uh, resin is made up of nano microparticles, sir.
Resin solutions.
It's a solutions.
Reagents is for we use the developer for reagent for developing some that devices that in SU8 we use the region na? Hello,
Sir?
Yes, sir.
can you
Resin?
explain again your doubt?
No, sir. It's commonly about photoresistors, sir.
What you tell me that three component of the photoresist?
Photoresist are resin, sensitizer, and one more is solvent, sir.
uh, what your doubt in that case?
So, with what material the resin is made up of, sir?
Okay,
For
resin what resin materials,
yes, sir. Does it made up of metal nanoparticles?
not nanoparticles. Resin is a solution.
Okay, sir. Then
It is made of
is
some
it used for developers, sir?
what
Is it used as a developer?
solvent will you use for a developer? We use the solvent.
Can you explain these three components, sir?
1 minute. First, I explained that SUV8.
Okay, sir.
So why we use the hard baking? That in that case, that two over and under developer we to avoid that in case that. In case of the SU8, we have the problem that when we have to develop the material when you are developing that patterns, there will be problem of the underdevelop or overdevelop. Okay, sometime the proper development will be done, not transfer of the pattern will be done in case of the SU8. So to avoid that underdevelopment or overdevelopment, we have to do the before the hard baking.
Yes, sir.
Sir,
Yeah,
pardon me, sir. I couldn't understand.
like that we have to remove this SiO2. See that this. Okay.
Okay,
So
sir.
it is a properly pattern. What will be happen in that case? Sometimes this will be 1 minute. Sometimes this will be like that. We want to develop only this. Sometimes this will be developed like that only. That this is means overdeveloped. These edges. Okay. Sometimes it will be not developed properly. This will be developed like that. That not the proper area that we have to transfer. It will be not transfer.
Yes, sir.
Means this we want this type of the transfer. But what will happen that overdevelopment underdevelopment will be happen in that case. So that's why because we want to that what we have to I already that we use that in that case. What we said, I have said you previously, Jabir, about I forget. We want to that photoresist. We want to that photoresist that resist will be solved in that UV light, that solvent. So we want to make that photoresist not too soluble in any solvent. That's why we do the hard baking before the exposure.
Okay, sir.
Okay, if it will be solved, then maybe that underage and overage effect will be happen during the etching of that process, and it will be damage our devices. So we will be do the hard means we make that photoresist hard, so that when the UV light will be exposed on that material, it will be not effect more effect. It will not make the soluble in that case. Okay, because SUV had the property of the solubility in case of if we not before the hard baking that UV, it will be etched in presence of the UV also.
Okay, sir.
So we had bacon expose.
Okay, so it will be broken. Maybe that the photoresist will be removed in that case of the UV light only. That we not need any etching and solvent. When we have to expose that, our photoresist will be remove that area that in the presence of the UV also. So if you see the property of the SU8, that polymers, you can read that in the chemical mode, that chemical people know more about that structure, that SU8, that bonding and that everything. What type of the bonding between that molecules and atoms in that case. And what is the effect of the UV light? Maybe that they have the van der Waals force, and whatever the external energy we have to apply, it maybe break the bonding in that case of in presence of the UV. Okay.
Yes, sir.
And if I find something, then I will be either share you on the email, or in the next class I will include also that doubt, also that more that explanation.
Okay, sir.
Okay. So
Yes.
definitely I will write that out, and I will explain some schematic diagram that why we use the soft bake and hard bake. Now I whatever that best of my knowledge that's why we use that hard bake after the soft bake. Okay.
Okay,
If
sir.
anything I will be found that more fruitful you and more clears, then I will include in the next slide also that.
Yes, sir.
Okay, this resin solvent and that what is the what we use in a resin solvent, and one is a sanitizer, and one about you that I will write and that I will include in the next class.
Yes,
This
sir.
okay, Zabira?
Yes, sir. Sir,
If you
I've
joining
one more doubt,
that,
sir.
yeah,
Is hard baking is done in SU8 in the case of SU8 double the times?
no, we cannot do the double times. If we
Sir,
can do the double times, if it not be properly done.
sir, is hard bake same as annealing or different thing, sir?
We do at a high temperature, same as the annealing. Like that soft bake, we have to do up to temperature of 50 degree, 60 degree. In case of the hard bake, we go to up to 200 degree Celsius, 300 degree Celsius, or 150 degree temperature.
Okay, sir.
So if we feel that it is not done, then we can do again the hard bake. Okay. It is a hit and trial. We have to optimize the temperature of the hard bake.
Okay, yes, sir.
So you can do the 2 times, 3 times, depend upon your application. If it's not done, you can do again that hard bake. It's not dependent. It will be changed that property. That you can do one time that only. By somehow your mistake will be done. You can do the 5 minute. Even people are increase the timing also that hard bake. Some people are doing for the 5 minutes. Some people will report it 10 to 15 minutes, 20 minutes.
Yes, sir.
Yes, sir.
Okay. So it's
Sir,
depend upon the users, that application, that scientific, that how can we people are operating that.
yes, sir.
Any other doubt?
Sir, in one of the questions, I think the order is quite difficult to remember.
Week 7.
What, sir?
Which questions?
Uh, it's one of assignment questions, sir, week 8 actually. So in that SU8 process, right? Before I shared a slide, right? In that slide, they said soft bake, hard bake, after that UV exposure. But in the assignment
Question number
question,
5.
what's sir?
Which question? Question number 5.
Yes, sir.
To fabricate SU8 pillars on chrome aluminum layer, with what is the sequence of process can be followed?
Yes, sir. Before that, I shared a slide, right?
Yeah.
In that slide, when you see the process of SU8, in that you can see soft bake, after that hard bake, and then UV exposure. But here the order is quite different, so and confusing.
See, you are confusing that. That's time they use for the drugs delivery. Drugs means that they use the property of the microbiology. Okay.
So okay,
They,
so here
they,
it
they
is.
have the design the microfluidic channel.
Yes, sir.
Yes, sir.
Okay. So
Mhm.
what will happen in case of the when we have to design a microfluidic channels? That design is a different than other design. That is not the standard process they have used it. As as per the applications of, or as per the sensor design, people are change the sequence through the standard.
Oh,
Okay,
yes,
sir.
sir.
This is the standard sequence they have mentioned. This is the standard sequence you have to follow. Okay.
Yes, sir.
But from that, if the from the standard sequence, if your device will be not made, then people are maybe that they change the sequence and they develop their device. Okay.
Okay.
That's why that you are confusing that they use the soft bake and hard bake before and exposure.
Yes,
But
sir.
like that there is a some like that if you see the example your question paper. Okay. What will be
Mhm.
examiner will be suggest that you have to answer the step by step questions. You have to attempt the first question, second question, third question, fourth question, and fifth question. But what we have to do? We have to do that. We whatever the questions we have to know first. We have to answer that.
Yes, sir.
Okay.
Okay.
So same thing in the developing of the device and what type of the device you have to fabricate it. Some people are using that they have to use the double lithography.
Yes, sir.
Yes, sir.
Okay. Like that if you want to CMOS, we want to fabricate CMOS, we use the double lithography. First we have to develop the source and then we have to develop the gate. Okay.
Yes, sir.
Some people what will happen, they have to develop the gate and then they have to develop the source and drain.
Yes, sir.
Someone using that back gate, they have developed in the upper layer source and drain here, and in the below they use the gate from the back side
Yes, sir.
because it is easy to take the back gate.
Mhm.
Okay.
Okay. Yes, sir.
Because there is a mismatch of alignment. If you not mark that proper alignment of your device, there will be mismatch of the gate and your device will be
And
maybe not be good.
patterns. Yes, sir. And
But
patterns.
for back gate, you have to develop the first source and then our upper, and you can take the back gate from the below.
Yes, sir.
Yes,
So
sir.
it is the application of the users and convenience. Okay. So I will note down that questions and I will take in the next class definitely.
Temperature.
Very good doubt you have to ask to me. So I will explain more about that in the next class then.
Okay, sir.
Yes, sir.
Okay. Maybe
Yes,
you
sir.
are aware, attend or not aware, I don't know, but I will take that questions.
No,
Definitely.
you
Sure, sir. We'll be attending, sir.
attending,
Okay.
sir.
Because we
Yes,
are
sir.
interested in this course, sir.
You have registered just now.
Yes, sir.
No, we enrolled for
Now,
examinations.
sir.
Okay, you enroll now for the examination.
For credit transfer purpose, sir.
Okay, so before you just are just for fun you have to enroll and you not want to willing to attend that exam.
No, we are going to write exam, sir.
We have
But
also
now,
registered, sir.
okay, okay. So you can ask to me that you can write to me ask to form question also that from week 1 to week 8 whatever your doubt. Okay.
Okay, sir.
Yes, sir.
Even you can post it to me my email ID that ashokbalota@gmail.com.
Okay,
Okay.
sir.
So we'll list it out, sir.
So whatever your doubt will be, I will include definitely in the slide. First, I will clear your doubt, then again I will remove that week 8 or week 9.
Okay, sir.
Okay.
So when is the next problem solving session, sir?
Next Monday, that's 7 to 9, Sam.
Okay.
And if I will, maybe the changes will be then your email will become that definitely to you that class will be rescheduled on that.
Hmm. Yes, sir.
I
Yes.
have, okay.
Okay.
So can we move? Continue.
Yes, sir. Continue.
Zabira.
Yes, sir. Sure, sir.
So this is the lithography process sequence. That this is the standard sequence. That okay. So what will be that? This is the that apply photoresist that through the spin coat, then pre-bake, then align and expose, then develop, and then post-bake. This is the standard process we use. Okay. Then inspect and measure means through the microscope we see the image that whatever that design will be exposed or not, that developing or not developing. It is over doubling and developing and under doubling we can check through the microscope, or we use the SAM or EpiSAM. SAM is the that scanning electron microscopy, and EpiSAM is the field scanning electron microscopy. These are the correct that characterization equipment we use to inspect that our devices and materials. Okay. So
Okay.
means so
Yes, sir.
through that optical microscope we can see the in the nanometer that the resolution we can zoom that our device will be developed or not developed, and if it is properly or improperly. Okay, like that in our case what will we have to do? We first deposit some material, then we have to do the coating of the gold or chrome or aluminum, what we have to do. Okay, and this is the chrome, then above that we have to develop the photoresist, and then we have to expose that materials, and then we have to do the etching and developing in every time. But some people, what will happen in case of the UV and EBL, they use that photoresist material, and they transfer the pattern, and after that they have to deposit the material aluminum, chrome and gold on that, and then they have to remove that unwanted photoresist material through the acetone. So it should depend upon the machine and availability of that device facility we have to use. Okay, so that's why
Yes,
that
sir.
maybe that this process will be changed in that case also. Okay,
Okay, sir.
Yes, sir.
so this is the lithography information following: design, mask, real image, latent image, resist image, device layer. This is the information flow. Follow this step can be destroying device pattern. This can lose information if we follow this image. ठीक है ना? So first we have to design, like that we have to design in the some whatever the design you want to transfer. Okay, like that you want to transfer like that this circular here, and these are the some strip. This design, you want to transfer your mask. Okay, you have to develop this design in any software, L edit, some that in EBL or EUV that company provides some that like that PPT type software they have to provide. You design your design here, then you transfer on the mask, and then this aerial image you have to see that there is a copper that one is a copper plate. So through the mask aligner, you can transfer this design in the copper plate. So in the ISC Bangalore, they have the facility of the mask aligner. We have in the IIT Jodhpur, we have now buy the machine of the mask aligner. So we can also develop the mask here also that. Then we have to create the real images, and then this is the photoresist, and then we have to device layer, transfer the device layer. So this type of the information will be follow in the lithography process. So it will be maybe now it will be not helpful in this lectures or this exam, but when you have to thought about the in the post graduation and PhD, it will be helpful in that case, in that data also that.
Yes, sir. Yes, sir.
Okay, sir.
Now it will be more detail. I am explaining the more detail beyond the lectures. Okay.
Yes, sir. It is useful for.
I will not cover that lectures. They have just explained the basic principle, what is the photolithography and everything, and what is the positive and negative. They just for your sake of knowledge that you have to aware about that. But I will go into deep that. So this is the mask, and this is the aerial image of that mask that transport, and this is the resist profile. We have check in the optical microscope. Okay. So
Yes,
this
sir.
pattern, this pattern will be transferred here. This. Okay.
Yes, sir.
So this is the functional component of the photolithography: vapor, photoresist, mask aligner, that energy, that light, UV light or that X-ray, that whatever you can use. Okay. So what is the energy that causes chemical reaction that modify resist dissociation rate? That they change the property of the resist. Okay. They make the soluble. Where they have to fall the light, they make the soluble in the solvent that resist. Otherwise, it will be hard bake or soft bake, so it will be not soluble, or it will be removed that in that case also. Okay, that mask aligner, that is a pattern that we want to transfer that image on the resist. That mask will aligner, like that we have the aligner that I will be explain that aligner in the next PPT also. These type of the aligner we have used, and in between that we have to transfer that our design. So we have to make the scale that it will be properly transfer on the material, that scale. So we use the 4 aligner here, that this is the boundary of that our devices, and in that boundary we have to transfer. Okay, like that we have the one plot, and if we want to, we have to make the 4 corner of the plot, and in between we have to design to fabricate our house. So first we have to make that at 4 block, and we have to measure the distance that it will be middle, that we have to make the that our design. Okay,
Yes, sir.
same things will be happening in the case of the photography also, photolithography. So this is the energy source we have to use the photolithography. In the light case we have to UV, deep UV and X-ray. And this is the energy and wavelength we have used in the photolithography. And these are the particles, like that EBL we have the electron and ion, not the optical. Okay. In case of the electron beam lithography, we use the electron. Okay. So that is the energy of electron and that wavelength of the electron we have used. Okay.
Yes, sir.
Anything in this? And how do energy we have to calculate? We have to use this formula. H is the Planck constant, C is the speed of light, and lambda is the wavelength of that lamp, that UV lamp or X-ray light. This
So we use X-ray mostly, sir, or UV
we
or
use the
deep.
UV. Mostly probably UV people are using 365 or 350 nanometer UV light.
So why not X-ray, sir?
X-ray, some people are using X-ray, but X-ray will be not given that at minimum design. The size X-ray we can design the future size of the 100 micrometer or 200 micrometer, and it have the distortion, more distortion of the mask.
Oh, yes, sir. Yes, sir.
It is the conventional technology people are using now. The recently people are using that this electrons and ions, EBL.
Hmm.
So we
Yes,
can
sir.
design in the nanometer future size of the device, 3 nanometer, 2 nanometer, 5 nanometers.
Yes, sir.
That we want to transfer this strip, parallel strip. So suppose that this is my source and drain. Okay.
Mhm.
Okay, sir.
And I want that distance between source and drain is the 10 nanometer. Okay.
Yes, sir.
So we can, it is not possible through this.
Mm.
We use to
Yes,
this.
sir. Yes, sir.
It is 10 micrometer, then we can use through the UV or deep UV. Any doubt?
No, sir.
No, sir. No, sir.
So this is the view the that mercury lamp, that wavelength, see that this wavelength we have used.
Oh,
Okay.
not bad. Yes, sir.
So this is the class of the light. Some people are use the mercury arc lamp, some use the excimer laser. Okay. So
Okay.
this is the wavelength that some people are using ultraviolet, deep using in even that deep ultraviolet 248, 193 and 157 at vacuum ultraviolet lamp. I think that you are not present at Zabir. I have explained about that effect of the UV, that sterilization and that everything that.
Sir.
Before that class, I have explained you about that. What is the role of the UV light in that in clean room, that UV sterilization and that lithography, that how it will be harmful for human being and that everything.
Sir, it causes cancer, sir. It
Yes, yes. That's
covers
why
skin.
we when we went to fabricate the devices, we have to wear the apron,
Yes, sir.
proper glass, eyeglass we have to wear, proper
Gloves.
that our
Yes, sir.
skin to be covered, everything we have to take care when we have to do the lithography.
Yes, sir.
Yes, sir.
Even it is done in the vacuum space or
Yes, in the vacuum we have also do
lab
the same.
session. We have seen like only hands are get into that closed
Yes,
areas.
yes, yes. And the hands will be covered with the gloves that will be protecting the UV light.
Yes,
Yes.
sir.
So this is the light source. We have the one arc lamp, that xenon lamp here. This is the mirror. This is the filter that filter the particular light, because xenon that lamp has the whole spectrum of the light. Okay, it will cover from that 100 nanometer to 220 to 2500 nanometer of the light spectrum. Okay, but what we want that, suppose that we want the 365 nanometer, so we use the filter that transmit only the 365 nanometer light only, and it will be reflected other light. Okay, and
Okay.
then we have the lens assembly. This light will be focused on the lens, and then we have to expose on the that laser, that per mask. Okay,
Yes,
so
sir.
like that we have that arc lamp. This light will be spectrum here like that. Then we use the filter that it will be transfer only the 360 nanometer, and then we have to, there is a mirror, because it will be split in many direction, and we want to coherent in only in one place. Okay, sport on the one palace, so we use the mirror, so it will be like that, it will be in the many directions, so it will be come here on like that one, this light on in one palace, sport on the one palace. So we use the mirror, lens assembly, we through the lens we can focus on the one spot. Okay,
Yes, sir.
any doubt?
No, sir.
No, sir.
So this is the extreme ultraviolet lithography, UV or UV, negative next generation lithography technology. In this, we use that expected that we use the wavelength of 3.5 nanometers of the light, 13.5. Okay, and it have the future size of that 15 to 16 nanometer of the future size of the device can be fabricated. And during the 7 nanometer post silicon node in the 2000, that in the 7 nanometer technology, we use the extreme ultraviolet lithography to fabricate the devices.
Yes, sir.
Yes,
Okay,
more resolution, sir.
yeah. So this type of the mask, okay, we use the chromium layer, 800 angstrom chromium layer we have to use on the glass substrate. So block radiation where it is not wanted, absorb radiation. That is the absorb radiation. मतलब कि that where we want this palace, this is the block, this is black color. Okay. So we
Yes,
want
sir.
not to transmit that radiation, we want to absorb that radiation. So that's why this is the black color. It will be absorbed that, and it will be transmitted through this transparent. So this will be not exposed. Means it will be absorbed the block, and it will be not transmitted. Means the photoresist will be not exposed to the light in that place.
Yes, sir. It's covered or
It's
it is
covered.
clear.
Okay. So need a opaque material at a desired wavelength. So this is the opaque material that will be transmitted maximum light on that where we use the opaque material, sometimes semi-transparent. Opaque means. Okay.
Yes, sir.
Okay, sir.
Raj? And this is photoresist, this is chrome, and this is quartz. We have to deposit the chrome here in materials. So photography emulsion on the sodium glass, cheapest outdated. Sodium glass means normal glass. Okay. Have you seen that normal glass that slide in your BTech or MTech in the chemistry lab?
Yes, sir.
In the
Normal.
first year, you have to do this one given to you some slide like this size, some small size glass slide.
Yes, sir. Yes, sir.
Huh? So that previously we used that the glass also as a substrate to fabricated of the devices because it is very cheap, available in the market easily. That the cost is not so much. But you can see that if you use the silicon wafer of the 2-inch diameter, this is the silicon wafer of the 2-inch. It cost is around 4,000 rupees. One silicon,
One
very high
silicon.
cost. Yes.
Yes, sir.
Okay. So
Okay,
if
sir.
the cost of the substrate cost is high, means your device that transistor cost is also high. But what in the market that transistor will be available for 1 rupees. Have you buy
Mhm.
any transistor in your BTech MTech project? BTech project in
Yes,
your
sir.
lab use the transistor.
It is very cheap.
It is 10 paisa, 20 paisa,
Yes, sir.
and you need the 1 rupees.
Yes, sir.
Okay, because there is a large scale development. We have to fabricate on the large scale. That why cost will be reduced. If you
Mhm.
fabricated one transistor, it will cost around 500 rupees
Yes,
in your
sir.
lab.
Mm.
Okay.
Yes, sir. Yes, sir.
Okay, sir.
So we use the different dimension of the silicon wafer, the 3-inch, 4-inch, 5-inch.
Mhm. Sir, and the yield of the silicon wafer differs, sir.
Yeah. It
Depending
is, it
upon
is
the
depend
type
upon
of
the
the
plane and direct planes. What type of the silicon wafer you use?
what type of silicon wafer.
Yeah, it's depend upon the planes. Either it is 100 type, one one
Uh,
zero type, one
oh,
type, 101 type. It's depend upon the silicon that what type of the silicon wafer you use.
oh, yes, sir. Yes, sir.
It's depend
And
upon the orientation of the silicon.
mhm. And why do we have a flat primary side, sir?
To identify
To identify what?
like that, this is the silicon wafer. We had the
Okay.
one primary flat here and one secondary flat here.
Mm-hmm.
So it will be like that. If this type of the angle will be zero, then this is the 100.
To identify the what kind of wafer.
Yes, to identify the type of the orientation, which wafer you
Oh,
have used.
okay, okay. Yes, sir. Yes.
Okay.
Mm.
Otherwise, it is a no meaning.
Yes, sir.
Okay.
Yes, sir.
So if you someone people will given you a vapor, you
Mm-hmm.
if I given you one vapor and I told you I will ask a question that what is the type of the vapor you told me that it is
We can
P type or
identify.
N type and what is the orientation of that vapor.
Yes, sir.
So
Yes, sir.
One
so
series.
people can identify through that flat type or either you have to do the XRD. X-ray
Mm.
diffraction uh, will be a technique that used to type that what is type of the materials that they use silicon.
Yes,
So
sir.
XRD is very costly, not available in everywhere. Okay.
Mm-hmm.
So from the whole 2-inch vapor, you can identify that this type of vapor I have to got from the vendor.
Oh, yes, sir.
Okay.
Mm. Understands.
You can use that things that also.
Yes, sir.
So this is the that mask we have to align that I have show you that positive negative photoresist,
Yes,
and
sir.
this is positive and difference that you can identify that H back process will be there. How we'll use H back means back type of the H back. Okay,
Mm.
Okay, sir.
that this is the lift of process. We lift that materials from here. That spring. Maybe I explain the next class because it is already 2 hours.
Oh,
Yes,
yes, sir.
sir.
This is the layers. I will. this how to be fabricated that mask. This is the tool L-edit. Okay.
Okay, sir.
So we have to make your devices in the L-edit tool. This is
Sir,
the
it is Cosmol.
yeah,
Is it Cosmol software or what
Console.
kind? Oh,
L-edit,
console.
L-edit, L-edit.
Oh, okay.
L-edit is a software will become
To fabricate these kind of things.
design. Whatever design we have to want to transfer that.
Oh, okay,
It's
okay.
mask creationers.
Yeah, this we want to create the mask. Okay.
Yes, sir. Yes, sir.
So this is the mask that is the and this is not for you. This type of lithography that whole machine will become.
Hmm. Yes, sir.
And this is the alignment. This is the alignment.
Yes, sir.
This is the alignment we have used. This is the vapor, and we have to align this for vapor. Peak there. See that. Okay. So
Yes,
this
sir.
is the mask aligner alignment. See that. This is the mask alignment will be there. This is the mask alignment. Yeah, these tools, and we have to make the devices. These are devices we have to make.
So,
See,
yes, sir.
see that this first layer. Then we want to second layer transfer. Then we have to again that we have to make the alignment of the second. So we identify that position of the alignment. We have to put the first alignment. So if we want to do the in the second lithography, that first we have to make the source, then and then we want to deposit the gate on above that. Then we have to align that gate aligner to with that below aligner also to position of that. So we want to remember that position also that. Otherwise that gate will be maybe deposit on above the source and drain also that. If you not properly make align that mask that. Okay. So that's why we use the eyeliner.
Yes, sir.
So this is the temperature that how will we mask alignment temperature. See that this is the exposure of this is the lithography. This machine. This
Yes,
type
sir.
of machine will become.
Yes, sir.
Maybe I will explain that this is the vapor state. This whole that machine will be there. This is the mercury lamp they have put. This laser will be go through that. There is some that projector lenses will be there. Project the light here. Yeah. Yes, Jabira.
Yes, sir.
Yeah. Tell me. Any doubt?
No, sir. No, sir. It was in
So
glitch,
this
sir.
so this type of machine will be there. This is a lithography schematic diagram.
Yes, sir.
Maybe I will explain that if you are available in the next class, then this is the clean room. How people are wearing that equipment and that.
Hmm. Yes,
This
sir.
image. Okay.
There was many videos, sir, regarding
Yeah.
the clean room and all.
Yes. Yes. So can you? We will stop here. Should I stop or should I continue?
Sir,
Jabir?
I have final question, sir.
Yes, sir. Tell me. Tell me.
So components of photoresist, sir.
That resin and that solvent and that
Yes, in solvent and then
So resin
that
solvent and
sensitize.
sensitizer, sir. What is the working and what's the purpose of these components?
yes, yes.
That not only I want to know, sir.
Okay, okay. 1 minute.
Yes, sure.
So are you in the third year or final year?
Sir, third year, sir.
So what your next plan
Next plan.
in futures plan?
Sir, I want to go to IITs for masters.
So you are preparing for the GATE.
Oh, yes, sir. Yes, sir.
Actually, we have
So,
attempted, sir.
Yeah.
We had attempted this year, sir.
yes, sir. We attempted this.
What is the rank?
Not qualified, sir.
Not qualified.
I have attended for double E. He was attending for
Easy.
EC, sir.
Acha.
Yeah,
So
I
it's
think,
around 25 marks cut off this time electrical.
Yes, sir.
and
Last time
easy is 30.
9.
I
Yeah.
wondered that the topper highest score in electrical is 66, sir.
Okay. So you are preparing online or so you use from coaching or self study?
So we just tried. So it was a trial attempt, sir.
Huh?
Trial attempt, sir.
You are
Sir,
using?
It's a
so
trial
no,
attempt, sir. That
she is preparing through self study, and I just bought some lecture videos from AS
Acha.
Academy.
Okay, okay.
Sir, I want to do my masters in VLSI or MEMS. So, what is? Do you have any guidance for it?
In the village side, you can yes, you can use the if you are ranked the good, then you can join IST, IITB, IIT Delhi.
No, before that they conduct interview, right, sir? Before joining MEMS or for VLSI. So that's why I asked.
No, means you have to qualify first the GATE.
yes,
Sir,
sir.
I
But
will
it
qualify,
is
sir.
Yes.
departments
So just ask the how will
procedures.
procedure.
When you have to qualify the GATE, you have to apply for the MTech position or that IIT have the one centrally system. So the IIT have the not centrally system. You have to apply for different IIT separately.
Mm-hmm.
So you have to apply for the different branch and like that estimation, MEMS, like VLSI, the communications, nanotechnology, nanosensors. There are a lot of the branch are opening in that. Like that new branches come that IoT, that MTech in the IoT, MTech in the cyber physical system, MTech in the machine learning with that MEMS sensors, that technology.
Yes, sir.
Yes, sir.
So you have to give to the preference and according to they have to conduct maybe some old IIT will be conducted interview.
Mm-hmm. So,
Old IIT, after that you have to apply that old IIT will be conducting an interview for the MTech admission.
oh,
Okay,
yes,
sir.
sir.
So they will be asked some basic question that if you apply for the micro VLSI, they ask from the semiconductor, what is the BGT, what is the semiconductor devices, what is the intrinsic semiconductor, what is the LED, what is the principle of the BGT, what is the principle of the CMOS.
Mm-hmm. So,
Yeah.
and for MEMS,
For MEMS, no, MEMS is the in the MTech you have to, they have not about the MEMS. The MEMS is the like that project work they have to do. Okay, like that
okay.
VLSI is the core branch. Some people are working in the cadence, the design part, like the CMOS analog type devices.
But
Some so when you have to do your major project or minor project, you have to choose the guide according to that. Okay, so if
Okay.
your choice will be that in the fabrication, so you have to contact the professor, sir. I am interested in the fabrication facility to design the CMOS or BGT or some devices. So he will be involved in that case. Some people are using that cadence tool that. Okay,
yes, sir,
so
yes, sir.
they, they are just simulating that analog devices, BGT, CMOS, and how will be that, that they will be check the timing, power delay. They are using the buffer and AND gate and NOR gate, and they have to make that whole the circuit. So it's
Yes, sir, yes.
so in the MTech they have the preference of the subject that you can take the any branch subject that chemical, chemistry, metallurgy, what subject you have interested you can choose and read, and after that in the major project you choose your project according to that.
Oh, yes, sir, yes, sir.
And in the PhD you can choose the particular topic, MEMS that. Okay. If you want
Okay.
to do the PhD, then you have to choose that particular process. You want to do the photon detector, gas sensors, or other application, memory or quantum dots design in the a lot of the application of that fabrications.
Yes, sir.
So it is your PhD topic. But in the MTech, you choose the VLSI subject, and you have to do your coursework, and then you have to for major project you can choose the MEMS.
Yes, sir, yes, sir.
For 1 year project, you can work on the 1 year MEMS, and you can publish the good page journal also.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So, like that region that mostly used that region is the epoxy. Okay.
Okay, sir.
Uh, the epoxy means we have to paste,
Mhm.
Yes, sir. It's a epitaxial layer.
not layer. Not epoxy is the different things. Like that, you have the two different material and you have to mix and you have to paste that things.
Okay, sir.
Yes, sir.
Okay.
Base materials.
Like that, I want to like that. This is the strip. Okay. This is the tab. Okay.
Okay, sir.
So what if I want to hold something, then I use the epoxy as a resin. So epoxy will call a resin. So this will be stuck,
Sticky.
sticky. So resin will be sticky. Means you want to stick your substrate on some material, so use the resin that time in the photolithography. Like that, you have to hold that sample. Okay,
Yes, sir.
on the mask. On below the mask, you want to hold the sample. How can you hold the sample?
How to
So
using
use
the
the resin. So epoxy is type of the resin. You can use the digilicrylate ether of biophenol, that DGEBPA called, to reacting bis bisphenol A with the aploquine, that ECS molecule weight controlled by so you use the different of the resin as per your the applications. Solvent means what type of the solvent you used to remove that photoresist, to remove the metals. Okay,
Okay.
like
yes,
that, you want to remove the gold, you have to deposit your gold here, that layer. Maybe like that, this is the gold layer. Okay, okay, and
yes,
you
sir.
want that this type of gold will be remain, and this I don't want this gold. Means, one minute, where I means this portion of gold you want to remove, and it will be remain, and this should be erased. Okay,
Yes, sir.
Yes, sir.
so you use the particular solvent that this unwanted gold will be removed. Okay, so there will be gold solvent will become. So some people are using mix in the ethanol, some are mixing that gold solvent, that to make that remover, that acetone, HF, and that these are different solvent will be available in the market. Okay, sanitizer means when you want to dry that things, so you have to either you have to sanitize in the temperatures, either you have to sanitize it in the UV light, either you have to blow the pure nitrogen or argon on that materials.
Okay, sir.
Okay, so you want to dry, and you have to remove that unwanted remaining impurity available on that sample you want to remove. Okay,
Okay, sir.
so when you either you have to go through that video through the clean room, people are blowing some air on that their samples, or some they have to use the hand blower, like that, push that hand blower. When you have you open your laptop in any repairing shop?
What, sir?
No, sir.
When how do you clean the dust?
In
Sir,
laptop.
I don't know.
If the dust will be on the laptop or some that critical critical parts of your devices, and there will be dust, then if you touch from your hand or any
Slime,
cloth,
sir.
that will be
I have
destroy
used
your part.
slime, sir.
Yeah,
Slime, sir. It's like a glue-like structure.
no, suppose that this is my critical, this is watch is my critical. Okay,
Okay.
and
Okay,
there
sir.
will be in that parts there will be stuck the dust. Now if I use the hand to clean that dust, maybe that will be destroy some parts of my watch.
Yes, sir.
Okay. Yes, sir.
Okay, so what will we
Mm-hmm.
use? Either I use some blower, pump. I will be
Blower.
push some air on that light, full of air, and in the presence of air it will be remove that, clean that. Okay.
Okay. Yes, sir.
So that's why we use the sanitizer component, that we want to remove some unwanted material. We cannot use the cloth or hand, or we cannot use the solvent. So what people are using, that pure nitrogen will become in the cylinder. They blow the pure nitrogen argon, or they use the hand blower. They like that. They push that hand blower here like that, and that time that some air will become and it will be remove something that from that material. Next time I will show the hand blower also, or I will show the video of my lab how people are using that. Maybe if I will be sufficient time.
Yes, sir.
Okay, sir.
Okay. So
Yes,
you
sir.
have to more understanding in presence in my lab. I will show you in the below my lab is there. So what are the equipment I have used? What is the I will show them our lithography also, that I have available in my lab also lithography. Okay.
Yes, sir.
So maybe you be understanding more in that case also.
Okay, sir.
Yes, sir.
So if you have any doubt, then you can ask two questions Google Form, because I have checked that today doubt also you that. Okay.
Okay, sir.
Yes,
Okay.
sir.
We stop or anything else?
No, sir. As of now, we are all
So
cleared about.
I hope that next time you will be join both of you.
Oh, sure,
Oh, yes,
sir.
sir. We will join, sir.
Huh?
Interesting.